This is Geometry Semester 1. It's the third unit called Area and Perimeter and the third lesson called Area and Perimeter of Circles Practice. It's on creatormath.com under the Geometry tab. You might have to Google creatormath.weebly.com. The instructions are copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. So just to show you that really quickly. Let's go back. Here's what you should be looking for, creatormath.weebly.com. Type that into Google. I hope you find the website. Here's the home page. When you show up, to know you're in the right place, should look something like this. All of the comp book stuff is down below here on the home page. Follow all the directions, watch all the videos. Let's go to Geometry Notes. All the notes, videos, vocabulary, etc. Table of contents is under the Geometry tab. Here's the PDF with all of the vocabulary. You can use this to help you do all of the practice sets that are on vocabulary for the entire year. Let's find the right semester table of contents. You've got to be wary of that to make sure you're not in the wrong one. And the one I'm doing right now happens to be in semester 1. It says Geometry Table of Contents, pages 2 through 6. You should have already copied this entire table of contents into pages 2 through 6 of your composition book. If you haven't done so already, stop now and do it now. This is Area and Perimeter unit. We have, what lesson are we on? Number 3. So we go 1, 2, 3 right here. It's Area and Perimeter of Circles. Here's the pages it goes on in your comp book. And just so you know, Area and Perimeter is the topic. We actually call Perimeter of Circles Circumference. We'll get to that in a minute. Don't look at these page numbers for setting up your comp book. Please go to the actual table of contents during the time you're watching this video. By the time you watch this video, these page numbers will likely be different. You're going to click Notes to know what goes on there. The first time they don't always load for me. Okay, in this case they did. You're going to put these notes into your comp book first on the correct pages as outlined on the table of contents. It's going to talk to you about circle area and perimeter. Right, perimeter circumference is 2 pi r with a circle. We have circumference as its own word for the perimeter of a circle. And you just have to remember that if you're talking about any other shape, it's the perimeter, it's the distance around it. If you're talking about a circle, it is now named circumference. Here are the area formulas for area equals pi r squared and pi d over 2 quantity squared. Here's an example of it. Here's how the area of a circle formula is derived. It's derived by cutting up a circle into pieces of pi, putting them reversed side by side, and making a rectangle and calculating the area. And you're going to get pi r squared because you're using the circumference. All right, so vocabulary circle. Circle is a set of points equal distance from one point called the center. The center is the point at which is equidistant from all the set of points called the circle. A radius is the distance from the center to the circle, and the diameter would be twice that. The diameter is from the side of the circle to the side of the circle through the center, and pi is the ratio of circumference to diameter, which in the old days you might have learned was 3.14. Hopefully now you know it's 3.14159.265, etc., and therefore we leave pi in instead of converting it to 3.14. Here's some information on a semicircle is half a circle. Units to the 1 power is length, units to the 2 power is area, and of course units to the 3 power is volume. Put this into your comp book, and then let's go and do some problem sets here, and that will help you move through some of these problems, hopefully. So right off the bat, why are the units of perimeter raised to the power 1? Because perimeter is one-dimensional. It is a length. And we'll do some examples to hopefully see how we get units produced in these different dimensions. A single dimension is just a length. It's going to be like feet. How long is it? It's feet. However, once you get to why are the units of area raised to the power 2, now we're taking a unit times a unit. By the time you multiply 2 units, you get units to the power 2. It's like taking x times x gives you x squared. So because it is two-dimensional. One-dimensional is the power 1, two-dimensional is the power 2, and you should know that three-dimensional is the power 3. So if we have a three-dimensional shape, length times width times height would be unit times unit times unit. Now you're going to get unit to the power 3. 3 dimensions, 3D, right? So I hope that makes sense. What are some common names of the 3 dimensions? Length, width, and height. That is one. Length, width, height. Horizontal, vertical, depth. Horizontal, vertical, depth. As you see, I'm tracing over the same dimensions, just different names. Don't worry so much about the names. Worry about which dimension you're talking about. And another one I think you could list here could be, you know, x-axis, comma, y-axis, comma, z-axis. I don't know if you know this, but this is the x, right? This is the y, horizontal, vertical, and this is the z. It comes out toward us, depth. Anyway, given the following circle, the diameter is 10, what's the area? All right, diameter is across here, this whole distance across here, and we always learn pick a name like dinosaur. That means the larger dimension here, and R, pick rat. And that's the smaller one here. A rat's smaller than a dinosaur, so that's how students, you know, they forget. Students will forget which one's the radius, which one's the diameter. They'll know one is each. They'll just mix them up. So that might help you. D for dinosaur is the one all the way across. This is 10. We know that the area of a circle is pi r squared. We don't have an r, we have a d. So area is also pi d divided by 2 squared. We're going to plug it right into that formula. And we're going to say d in this case is 10 units. And we're going to put units right into our calculations, divided by 2, and square the whole thing. Area is going to equal pi here. 10 divided by 2 is 5. Units squared, let's keep 10 divided by 2 is 5, squared, still squared. And units to the power 2 is units squared. And that's good because we need that for an area, 2 dimensions. Area equals 25 pi units squared. 25, that's a pi right there. It's really hard to see. A little pi right there, units squared, 25 pi. We do not change out the 3.14 anymore. Why? Because this symbol carries with it all the infinite digits of the irrational number that pi is. And therefore, leaving the pi symbol in is the most accurate way to leave the answer. If we replaced it with 3.14, we would incur a rounding error because we cut off all those extra digits. Given the following circle, if the diameter is 10, what's the circumference? Okay. Circumference equals 2 pi r. Circumference equals 2 pi. If we have r, we can replace it with d over 2, because d divided by 2 is r. Since there's a 2 and a 2, c equals d pi. All right, d pi in this case, d is 10 units. And that's times a pi. And it just comes out c equals 10 pi units. All right, there's no units times units. That's why it's units to the 1 power. So 10 pi unit to the 1 power is the circumference. That is the distance around the shape. If you started here and walked all the way around, once you got back to here, you would have gone 10 pi units. If it was feet, it would have been feet. Given the following circle, if the radius is 6 units, what is the area? So now they're telling us the radius here is 6 units. Okay, so we have area equals pi r squared. Area equals pi 6u squared. Notice we put the units right into the calculation. It gets involved too. Area equals 6 times 6, because that's squared, is 36. The pi stays in the answer. It doesn't go anywhere. And units times units becomes units squared. And that's good because an area requires units squared. So 36 pi, that's a pi right there, units squared. Given the following circle, if the radius is 6, what's the circumference? This is 6, c equals 2 pi r. C equals 2 pi 6, and let's leave the units in there. All right, 2 times 6 is 12. 12 pi units. That's a pi right there. It keeps getting washed out when it prints. 12 pi units. And notice it's to the power 1, so is ours. There's no units times units, so it can't be units squared. That would be an area. So if you're paying attention to units, they can actually help you understand your answers and understand what it is you're calculating. Why do we leave the pi in our answers instead of substituting 3.14? because the symbol pi represents all infinite digits of pi and is therefore more accurate than using 3.14. This should be 3.14, and this should be an S, which is only an approximation of pi. Okay, so these errors avoided us from reading the real answer here. Because the symbol pi represents all the infinite digits of pi and is therefore more accurate than using 3.14, which is only an approximation of pi. All right, this is how you derive the formula of pi r squared, given the circumference is there's 1/2 the circumference here. So there's 1/2 2 pi r. That's this length here. So we've taken this circle, cut it up into pieces of pi. Here's a piece of pi. Then we've laid them crust out. Here's the crust, here's the crust, here's the crust, here's the crust, right? And we've done this very small. Imagine doing smaller and smaller and smaller and smaller pieces of pizza, all right? The smaller the pieces of pizza are, the more accurate this starts to look like a rectangle. And we know how to calculate the area of a rectangle. It's base times height. The height of this thing is radius. So get rid of these 2's. We have pi r times radius. So pi r times radius would be base times height equals pi r squared. Oh. That is how you come up with pi r squared as the area of a circle. All right. So make sure you're matching up the title of this lesson. This one is Geometry Semester 1, and it's the 3rd unit called Area and Perimeter, and it's the 3rd lesson called Area and Perimeter of Circles Practice. It's on creatormath.com under the Geometry tab. Hope this helps.